A steak hits the pan, that sizzle you hear, chemistry screaming. Within seconds, the gray meat turns a deep, glorious brown. This is not burning, it is a transformation. The same magic crusts your bread, your coffee, your roasted onions. Hundreds of new flavors appear that were never there before. Over 1,000 distinct flavor compounds can form in a single seared steak. Raw food tastes flat, cooked food tastes alive. Why? The answer is a reaction named after a forgotten Frenchman. He discovered it by accident, then died before anyone understood it. Paris, the year is 1912. A young physician and chemist, he was studying how proteins form in the body. He mixed amino acids with simple sugars and gently warmed them. The clear liquid slowly darkened into a rich, golden brown. He published his findings, but he was chasing biology, not cooking. He had no idea he had explained the taste of nearly all cooked food. For decades, his discovery sat ignored in a journal. Chefs brown meat every day without knowing the chemistry behind it. It took roughly 40 years before science truly returned to his work. Then a chemist in the 1950s finally cracked the full picture. Working at a U.S. Department of Agriculture lab, he mapped the reaction step by step. In 1953, Hodge published the scheme that mapped the full reaction. So what actually happens in the pan? It begins when a sugar molecule bumps into an amino acid. They join, rearrange, and break apart into unstable fragments. Those fragments recombine into hundreds of aromatic new molecules. The reaction speeds up sharply above 285 degrees Fahrenheit. Below that, food just steams. Above it, the browning begins. This is why boiled chicken is pale and roasted chicken is golden. Water is the enemy, it traps heat at the boiling point. Dry the surface and the magic accelerates. That is why chefs pat a steak dry before it hits the pan. People often confuse this with caramelization, but they are different. Caramelization is sugar alone, breaking down under heat. Maillard needs both sugar and protein, dancing together. Most brown foods involve a little of both at once. And the flavors it creates are staggering. Roasted, nutty, meaty, toasty, malty, all born from this reaction. The crust of bread, the skin of a roast turkey. Dark beer, soy sauce, chocolate, and your morning coffee. Coffee roasting can generate over 800 aroma compounds through Maillard chemistry. A family of molecules called pyrazines gives roasted food its signature smell. Cooks for centuries chased this flavor without naming the science. The French knew searing meat created depth, they called it a craft. But the Maillard reaction is not always your friend. The same chemistry that delights your tongue can form harmful compounds. When starchy foods brown too hard, they can produce acrylamide. In 2002, researchers first detected acrylamide in cooked starchy foods. It is classified as a probable carcinogen. Burnt toast and very dark fries carry the highest levels. Health agencies now advise aiming for golden, not brown. The goal is balance, deep flavor without charring the food. Maillard reminds us that flavor is not added to food, it is created. Heat unlocks tastes that were hidden inside the raw ingredients. Every kitchen is quietly running a chemistry lab. Louis-Camille Maillard never tasted his own legacy as flavor. He saw molecules, we see breakfast, dinner, and comfort. Next time your bread toasts golden, remember, that smell is a reaction over a century old.